Hey y'all, Miss Kennedy here from Algebra Student, and today we're looking at graphing linear inequalities without technology. Whew. If you've ever done it, if you've ever seen it done with technology, like watched a Desmos graph or something, oh my goodness, you're just going to feel like you're in like caveman times and when you're doing this because it's going to feel really slow and tedious. And yep, it does. There's a lot to it. There's a lot of pieces to it. But it's not the most horrible thing you'll ever do. And sometimes we have to do the hard things. So this is one of them for algebra for sure. All right, so I have problems on the screen that we're going to take a look at. We're going to do one system, and then if you stick around to the end, you'll see another one where I'm going to give you some extra tips and hints for this. So hit subscribe. I'm going to help you make sense of algebra so that you can understand it and move on with your life. All right. So first things first is we're going to graph the two inequalities. So we're going to start with y is greater than or equal to 1. And the nice thing is it's already solved for y. So we can just jump right in. That 1 at the end tells us that we're going to go up 1 and put a point. And then it looks kind of funny because y is greater than or equal to 1. There's no x in here, so there's like not a slope. So that tells us something. That tells us that we're either, doing a vertical line or we're doing a horizontal line. And so, the way you want to think of this is that no matter what x is, y is greater than or equal to 1. So if x is 6, y is still up at 1 or above. If y is -8, if x is -8, then y is up at 1 because this is our x and our y axis. So we've got a nice little line here, and I'm going to use that. Let's see if I can do it on the first try. I don't know if I can. Let's see if I can get it to... Yeah, all right, that works. Okay, now let's see if I can figure out how to make it go away. Technology. Okay, so I did a solid line because of the greater than or equal to right here, and I need to shade above because it's greater than. I could do a test point if I want to test 0, 0 and see if I need to shade down here on 0, 0. Then I would go into y is greater than or equal to 1. This is my x and my y, and plug in a 0 for y. Is 0 greater than or equal to 1? No, it's not. So I don't shade where 0, 0 is. I'm going to shade up here. Oh boy. And I hit the button. Let's see. Let me try that again. Blue. All right. So yeah, there's my shading. Not pretty. That's one of the struggles that I found as a student and even as a teacher. It's not pretty when I do it. It's not this beautiful, lovely, whatever. I wonder if I shaded with highlighter, but I don't. Oh, I can. All right, let's try it. Ooh, that was nice. Okay, so blue. All right. Now, can I change the size? Everybody watching is going, oh my gosh, why are you taking so long? Okay, let's see it. Oh, yeah, that's pretty. Okay, so let me undo now did I undo the setting? No. Okay. So I'm still not pretty, but maybe it's better. Ooh. Can I erase just that little piece? Nope, it's going to erase the whole thing if I do that. Oh, no, it didn't. Okay. You may not ever see this video because I may just decide that's ridiculous. Okay, so now we're done with that part. We know that those are all solutions up here in this direction. These are all solutions to y is greater than or equal to 1. Anything that's on the line, because it's solid, and anything that's above the line is a solution to that. But this is a system, and systems are two inequalities or two equations. And so now I've got to solve for the other one. So I'm going to solve for y. So my first thing is that I want to move the 4x over. So I've got 2y is less than, and now remember I want the x first and then the number. So I'm going to put negative 4x plus 6. Remember, you don't add them together. It's not 6 minus 4x and get 2x. If it was 6x minus 4x, that would be 2x. But this is a 6 and a negative 4x, and you don't put those together. You just keep them separate, and I'm listing the x term first. Okay, now I want to divide by 2, so I'm going to go through. Why did it make it a parallelogram? Divide by 2 all the way through. All right, so I divided by positive, so I don't change the inequality. It stays less than. How do I do that? All right, technology. See, I really do love technology. I just need it to work for me. Okay. All right, so divide by 2. So y is less than negative 2x plus 3. Okay, so now I can solve. Now, wouldn't it have been nice if I thought to change my pen color before I did all that, because I'm getting ready to graph, and I want to see very differently that this is what I'm graphing and where the differences are. Okay, so negative 2x plus 3. So I'm going to go up 3, 1, 2, 3, and put a point. And then this is my slope. My slope is negative 2. And so for rise over run, I know that's negative 2 over 1. It's always over 1 if it's a whole number. So this is my rise and my run. And the negative tells me I'm actually going to fall 2. So I'm going to go down 2 and right 1 and put my point here. Down 2, right 1. And I mean, you could keep going. You could go up 2 and left 1, but you get the idea. Let's do our little happy little rectangle. I don't know. Okay, we'll try it. Let's see if the line's going to look nice there. Okay, now I just did a solid line. Is that right? No, because why would I be talking about it if it wasn't? So notice that right here, this is less than. It's not less than or equal to. So I'm going to take that off, and I'm just going to do a dashed line through these points all the way through. Okay, so now I'm going to turn off the ruler, and I'm ready to shade. I'm so sorry. There's got to be a way to lock that in. I have Googled it and I can't find it. So if you know how, please comment and tell me how to lock in the size for whatever I'm on. Inkboard, Inkspace. I think it's Inkspace whiteboard. Okay. I think it has to do with that I'm not using a Surface pen. I'm using my own little bamboo Wacom stylus thingamajig. I don't know what it's called. All right. So I'm going to do a test point. I'm going to test 0, 0, because I want to see if I'm going to graph here at 0, 0, or if I'm going to graph on the other side. So I'm going to go back to the original. So let's plug into that. 4 times 0 plus 2 times 0 is less than 6. And we're testing, is that true? So 0 plus 0 is 0. Is 0 less than 6? Yes, 0 is less than 6. So that tells me that I'm going to highlight where the 0, 0 is. So I'm going to pick this one, and let's see if I can. Yep. Okay. So that generally tells me kind of where my lines are different, and it might even help to be more not to do that. See? Oh my goodness. Yours is going to be a lot better than mine. I'm just trying to shade more here to see. Okay. Oh, that's really, really not pretty. Okay. Whew. So that looks purple. We're going to use our imaginations, but we are really focused on that section that is, let me make it purple, that is both. right? It's both the blue section and the red section. Okay. Oh my gosh, I think it's worse than it was. Okay, so here's what I'm saying. Let's get a black pen and really notice what we're saying. We're saying that there are not solutions out here. And there are not solutions here. There's not solutions here. There are no solutions here. I'm saying these are not spaces where there are solutions. And this is definitely no solutions because nothing's graphed out there. To be a solution, you've got to be in the section where the blue overlaps the red, or whatever two colors you use for shading. It's where your shading for one inequality overlaps your shading for another inequality. That's your solutions. So sometimes the question is, state three solutions, or what are three solutions to this problem? And so we could say, this is a solution, and this is a solution, and this is one. And so that would be -9, 3. That's a solution. And -3, 3 is a solution. And -3, 6 is a solution. Okay, so that would be three solutions. Or the question might be, is 3, 0 a solution to this problem? Well, 3 zeros here, no, it's not a solution. Is -6, -6 a solution to this system? No, it is not, because it's shaded for one inequality, but not for both of them. Is 9, 3 a solution? 1, 2, 3, 4 a solution? No, it's only in the blue shaded section, but not in the red shaded section. Okay, so I hope that helps. Oh my goodness, what an ugly picture. That's just terrible. If you get the chance to check it out using technology, you're just gonna be like, oh my gosh, it's so much better looking than anything Miss Kennedy ever did. So yep, that's true. That's the way it's going to look. But hopefully you can sketch it and shade it in such a way that it's going to make sense to you. I will tell you that one thing that's really helpful, like when you're on your own paper and you don't have the benefit of just, let's just flip over to this other color, I would shade it in pencil or whatever, and then just kind of go over it lightly with a crayon or a colored pencil or a highlighter, use that. And then try to use colors that are going to be real distinctive to you and whatever works for your brain. And then go ahead and do the second one and then shade for that. And then hopefully you can see that overlap even better than if it's just pencil overlap. Okay. All right. So for those of you who stuck around with me with all that craziness going on, let's take a look at this and let's see. I'll stick with that red for now. Let's go ahead and do the first inequality. So this one's already solved for y. Yay, that's always nice. This tells us that we're going to start by going up 1 and putting a point because that's our y-intercept. Remember, this is our x and our y. And then we're going to go up 5 and right 1 because rise is 5 and run is 1. So up 5 and right 1 puts us here. Or we could go down 5 and left 1. And that'll put us in line. All right, let's see. Come on. Oh, I almost had it and then I missed it. Oh my goodness. Yeah, I'm glad I have a touch screen, but wow. Okay, sorry, I'm just like driving you crazy. Okay, I almost drew that straight line again, that solid line, but it says less than, so I need to just do a dashed line through my points all the way down through the graph. You want to go throughout the graph and put arrows on both ends, and it's less than. Let's test point. Now 0, 0 is really close. And you might even want to pick one that's not close so that it's like farther away. So I'm going to pick 1, 0, and we're just going to see if 1, 0 is it. So my test is going to be 1, 0. And so that's my x and y. And so I bring this inequality down. And so y is 0 less than 5x plus 1. So wherever x is, you put parentheses, x is a 1. 0 is less than 5 plus 1, which is 6. Is 0 less than 6? Because that's our question. Yeah, sure it is. 0 is less than 6. So that means that this is a solution over here at 1, 0. And so what I'm going to do is go ahead and highlight that, and let's pick a color that's a little closer. All right, so I'm going to try to go right up to it. And then shade, shade, and shade. Okay, so everything on the right gets highlighted. And now I'm ready to do the next one. And let's do this blue. This is a fun little blue. And okay, so I need to solve for y. So I'm going to subtract 6x again and bring down, it looks like I crossed out the negative, bring down the negative 9y greater than or equal to, and remember it's not 18 minus 6x to get 12x. You don't put them together. It's 18 and it's a negative 6x and they stay separate, but you want to put the negative 6x first because you need the x, the slope part first. Okay, so I'm going to divide by negative 9, all the little pieces. I divided by negative, so I've got to remember to flip the inequality. So greater than or equal to becomes less than or equal to. Negative 6 over negative 9 reduces to 2/3. And then negative 18 divided by negative 9 is a positive 2. All right, so I'm ready to graph. So I'm going to go up 2. And I'm going to go rise over run, up 2 and right 3. So 1, 2, 1, 2, 3. And it's less than or equal to, so I know that I'm going to do a solid line. Well, let's see if I can do this a little faster than I did last time. That's not exactly right because I know it's going to be here. Okay, thank you for bearing with me because I was being real picky about that. Okay, solid line. So I can go this way and put my arrows. And now I need a test point. I'm going to test 0, 0. So now I'm going to go way down here. 6x minus 9y greater than or equal to negative 18. And I'm plugging in zeros. This is why I plug in 0, 0, because that just all goes away and it becomes 0. Is 0 greater than negative 18? Yeah, 0 is bigger than negative 18. Much better to have $0 than to have negative $18, to owe somebody $18. All right, so that's a true statement. So that means 0, 0 should be graphed. It should be part of the graph shaded area. So that means I'm going to start out here and I'm going to graph. And, ideally we would have it really, really, really clear. Okay. All right. Well, I like the way that sort of changed when I let go of it. You can kind of see here's our section here of solutions. And so, if we were going to name solutions, here's a solution at 3, 0. That's a solution. Here's a solution at 6, negative 4. That's definitely a solution. Here's a solution over here at negative 1, negative 8. That's in both parts. Of the red inequality shaded and the blue inequality shaded. And so those are solutions to the system. What's not a solution would be up here, over here, in this section, or this section, or this section. None of those are solutions because they're not in the red and the blue section. And understand that this keeps going. The shading stops out here and out here, but those solutions continue infinitely in those directions. Okay. So if I asked you, is negative 1, 1 a solution? Negative 1, 1 is here. That is not a solution because it's just in the blue shaded section. So it fits for one inequality, but it doesn't fit for the other. Okay. Whew, not pretty, but I hope it helps. Thanks for watching.